Hi everyone, this is Valerie from Arizona Science Center here to do a chemical reaction with you today. And the chemical reaction that we're going to do is called iodine clock. So I have a bunch of ingredients up here today, and before we get to it, we do want to talk a little bit about safety in chemistry. So before we start our experiment, I want to remind everybody that anytime you use chemicals, even if they're not super dangerous chemicals, you do have to worry about them getting on your skin and being irritating. So anytime we do anything with chemicals here at the Science Center, we always wear our protective equipment. So I have my safety goggles on. These glasses are on even though I wear glasses, just to protect me from spills on the side. I also have my hair up so that I don't get any hair in the chemistry. I have my gloves on to keep my skin protected. I have my lab coat on to keep chemicals from getting on my clothes, which could reach my skin. And even though you can't see my feet, I am wearing closed-toed shoes, and you should always wear closed-toed shoes when dealing with chemicals because you don't want any chemicals on your skin, including your toes. So don't wear flip-flops or sandals. You always want to wear good protective equipment. And today, the chemicals we're dealing with may not be ones you have at home, but you might recognize some of them. And we're going to talk about each one of them and then how they might combine to form a reaction. So anytime we do a chemistry experiment and we're looking for a reaction, remember we want to use all of our senses to see if a reaction has occurred. So we want to look with our eyes to see if something happens. Maybe it'll change color, maybe it'll do something exciting. We want to use our nose. Sometimes we might smell that there's been a reaction. We could hear bubbling or some other noise coming from our reaction. We could feel a change in temperature. So all of those senses we're using for our chemical reaction to see if a reaction has occurred, but we're not gonna taste the chemistry today. If you were doing some kitchen chemistry, you might also use your sense of taste, but today we're just gonna use those other senses, and we're gonna make observations to see when a chemical reaction has occurred, if a change has taken place. So that's what we're looking for, to see if when we combine ingredients, we can create something else. That's really what chemistry is all about. So we'll make some predictions along the way and see if we can create a different colored solution from the one we started with. So that's gonna be our goal today. So starting off on either side of my table, I just have some regular water right here. Regular H2O came straight out of the tap. The first thing that we're going to add to the water is iodine, and that's what this reaction is named after, the iodine clock. Iodine, if you take a look, is very dark brown, and it is often used in medicine on cuts. You might have seen it before if someone put a kind of a disinfectant on you. It's a very dark brown color. I measured out 10 milliliters in this little graduated cylinder. And when we put it in our container of water, you can already see that something has happened. All right, it's turned brown to match the color of our iodine. All right, but the next thing we're gonna do is we're gonna add a little bit of ascorbic acid. Ascorbic acid is the same thing you can find in a vitamin C tablet, except this is ground up already into a powder that we can add. So we can make a prediction right now. When we add this ascorbic acid powder to this liquid iodine solution in water, what's gonna happen? Make a guess right now. All right, I'm gonna go ahead and add it to our solution. And then I am just gonna get a little stirring rod and we're gonna stir it around, and oh my goodness, look at what happened. It has turned perfectly clear again. So we have already done some science today. We've turned this brown solution back to clear. And you can actually see why in the olden days, we'd have magic tricks going on maybe on the streets of chemicals being put together, and it looks like magic. We use some kind of special formula or magic spell to turn it clear, but actually it is just a chemical reaction. Our vitamin C is interacting with our iodine to turn it into a clear form. So we have just a little bit at the bottom that I'm gonna stir up, and we're gonna leave that there for just a minute because that's not the only reaction we're looking for today. On the other side of our table, we have another beaker of water here, same amount of water, but we're gonna add a couple other things to this one. We're going to start with some hydrogen peroxide. You might find this at the beauty salon or at home in your medicine cabinet. Hydrogen peroxide kind of foams up if you put it on a cut, you'll see, or you might use it to bleach things. So we're just gonna add this clear-ish solution to our water, and we don't see much of a change. All right, we're adding something clear to something clear, so probably not gonna see anything. But we also are going to add this starch to our solution. Starch you might have used in your slime recipes at home, but it's often used in laundry to get wrinkles out. And we are going to add 10 milliliters of this liquid starch to our hydrogen peroxide and water solution. So you can make a guess right now whether you think anything's gonna happen. Here we go, I'm gonna add it in. And I'm gonna stir it up just a little bit, but pretty much you'll see it's a little cloudy, same color as the starch, but not much else has happened. And here's where we're gonna see if we can create a new color, putting our two clear solutions together into one beaker. All right, so before we do this, you're going to make a prediction. What do you think is gonna happen when we put these two solutions together? You can even write about it in the comments below. If you've ever done the iodine clock, you might guess that we're gonna try to make something that's a different color. That's all I'll say. I don't wanna give it away. All right, so here we go. I'm gonna get the last of this out. The last of this out. And then we do have to wait a little bit. So this reaction is called iodine clock reaction because some time has to actually go by. It's a bit of a time release reaction. And something that you can do to kind of speed it up is swoosh it back and forth between two beakers. So we'll see if this speeds it up at all. And now all we're doing is kind of mixing it up by pouring it back and forth between these two beakers, or flasks really. All right, so still looks the same, still kind of a, what do we call that? Cloudy, clear liquid. Hasn't changed yet. We're still looking to see if anything has changed. You can also just let this sit and see when the reaction will start. It's something that does take a couple of minutes. So as we're pouring it back and forth, we're looking for a change, for the iodine to interact with our other chemicals and to turn a different color. You see a different color yet? Nope. All right, we'll keep pouring here. And sometimes when we do this experiment, we tell everyone to think ink, because we want to turn this dark enough that we could almost use it as ink. Still don't have a change. Still just going to let it sit, have the timed reaction go off. What do we think is going to happen? Sometimes it takes a few minutes. Now, if we were doing a magic trick, we would definitely have our audience saying some kind of enchantment or magic words to make it work. But the timing can be tricky because you do want your reaction to happen right when they say the magic word, like abracadabra. All right, still waiting. Still see if anything happens. Nothing's still happening. Keep pouring it back and forth. Remember that chemistry is a lot like following a recipe. So we're following our recipe, and now this is like when you put it in the oven and you bake it and you're waiting for it to turn into something different. This is kind of like our cooking time, except we're not adding heat, we're just adding time, and we're we're doing a little bit of mixing back and forth. Oh my goodness, did you catch it, Cole? Oh, I think you zoomed in just exactly at the right time. So you can see why sometimes we say think ink. It is now turned so dark that it looks almost like ink. So I'm gonna have my cameraman Cole come in and take a look. Now we're using our eyesight as our observational tool to see that a reaction has occurred, because it did go from a clear or cloudy substance to this dark substance. And this timed reaction is all about the iodine. So when we added the iodine in the ascorbic acid, remember that the ascorbic acid made it turn clear, right? And it's kind of keeping it in that clear form. Once we add that iodine mixture to the hydrogen peroxide is what's eating away at the vitamin C tablet, at the ascorbic acid, and once that's all gone, then it's gonna turn back to a brown color. Now, this isn't brown. Our brown iodine actually reacts with the starch and turns this almost black, deep purple color. So we have a number of reactions happening that created our big color change. And remember, chemistry is all about observing, right? And we want to use all of our data then to make some kind of conclusion about how these chemicals work together. Don't forget that you can do more exciting activities and see more exciting demos at azscience.org. And you can also visit us on our social media platforms. We have videos on Facebook and YouTube, and we have posts on Instagram as well. So thanks for visiting with us today, and we'll see you later.